Hi everyone, today's video is on section R.3 and it's regarding polynomials. And so we have a couple different vocabulary words and definitions we need to get down, a little tiny bit of practice, otherwise pretty straightforward information here. First word we're going to talk about is polynomial, and it is a term or sum of terms that has only positive, integer, or zero exponents. Let me zoom in and kind of write this down here. So the first requirement is it has to be a positive integer or zero exponents. Okay, so I've got a couple examples down here. The first one, the first example is a polynomial, 4x to the third minus 5x plus 1. All of the exponents on any of the x's in that entire expression are either positive integers or zero. Okay, so the reason why this second one is no is because of this square root right here. That's an exponent on x that is not a positive integer and is not zero. I'll give you a couple other examples of no's. One of them would be like 3 over x plus x squared. That's because the x is in the denominator. Another example would be having a different negative exponent. So I could have something like 7x to the negative 3 plus 4x squared plus 5 or something like that. The fact that the negative 3 is there makes it not a polynomial, and the fact that this is an x in the denominator makes it not a polynomial. So a couple of things to be looking for that makes something a polynomial and something not, okay? Another thing we need to talk about is the word degree, and it is the exponent on the variable, and if there is more than one variable that has an exponent, then the degree equals the sum of the exponents for that term. Okay, so we can look at this first example, 4x to the third. The degree on the exponent on the x is 3. That makes this have a degree of 3. But then the question arises like the second example, what if there's two different variables or two different letters down there? So you add up the degree or the exponents on all of the letters or all the variables. So it's x to the first. You know how there's a 1 exponent there? If there's nothing, it's understood to be a 1. So it's x to the first and y to the fourth. So what we're going to do is add those together. And so we end up with a degree of 5. So if there's only one variable, the degree is just whatever the exponent is. If there are multiple variables within that term, then you add up the exponents of all of them. So I can give you another example here. What if it was 2x to the fourth, y to the third, z squared? The degree would be 4 plus 3 plus 2, which is 9. Okay, so just there could be multiple variables with a bunch of different exponents. You add them all together if it's within the same term. So that's kind of rule number 1. And then we have this word degree of the polynomial. So look how many terms we have down here at the bottom. Here's the first term and here's the second term. And so the reason why we have multiple terms is that they're not like terms, they can't be combined. So what we have to do is figure out the degree of each term individually. And then it says the something degree of all the terms of the polynomial, so it's the highest one. So if there are multiple terms within the polynomial, you choose the largest degree to be the degree of the entire polynomial. So think about that. This degree of this term is just 3. And the degree of this term is you take your 2 and your 6 and add them together and get 8. And so therefore the degree of the entire polynomial, degree of poly, equals 8. It's always the largest one for each term. Okay, so a little bit of vocabulary and definitions there to get us started. And then there's a couple charts down here that we can talk about for types of polynomials. You can name polynomials by both the number of terms, which is the first section, and the degree, which is the second section. So each polynomial technically has two different names that define it. So let's talk about this very first example here. We have an x, which has a 1 exponent, and we have y squared and z to the fourth, so that makes the degree 7. And this is called a monomial. Mono means 1, and that's because there's only one term in this example. Okay, so going on to the next one, the binomial, you know that bi means 2, just like a bicycle has 2 wheels. And that has two terms. So there's 4x and there's -3. That's two terms. And then we talk about the degree of the polynomial. So find the term that has a variable. So the 4x is the term that we're looking at. And what's the exponent on the x? The exponent is 1, so that makes the degree 1. And that's because there's a 1 on that x there. Okay, trinomial means it has three terms. 1, 2, 3. Tri means 3. And let's do the degree of each of those terms. The first term has a degree 3 because it's x to the third. The second term has a degree 5 because it's x to the fifth. And the last term has a degree 0 because there is no x there. So our highest degree for that entire polynomial is 5. So the degree of that polynomial is 5. Okay, and then I have a none down here just because I wanted to kind of reiterate some examples that are not polynomials. But I'm going to use the fact that it has two terms. Means it has two things in it separated with pluses and minuses. So remember our examples that are not polynomials. One example would be like 5 over x plus 2x squared. That has two terms, but it's not a polynomial because of the x in the denominator. Another one would be -2x to the -3 plus 5x. Again, it has two terms, but it's not a polynomial because of the negative exponent. So since it's not a polynomial, it also does not have a degree. So this is kind of a lot of definitions and vocabulary here. You do need to be familiar with these vocabulary words: monomial, binomial, trinomial. That determines how many terms are in the polynomial. We also have names depending on what the degree is. So this very first example, and the second one, has a degree of 1. And that's the highest degree in the entire polynomial, so therefore we call it linear. And you could kind of think of it as in terms of, do you remember from Algebra 1, y equals mx plus b? Remember how the exponent on x is 1? And you probably remember that formula y equals mx plus b with slope and y-intercept. Those are all lines, if you remember, like graphing lines on a coordinate axis. And so that's why they're called linear, just kind of a fun fact. The next one is a degree 2, which means the highest exponent on any of those variables is a 2, and we call that quadratic. The next one is a 3. That's the degree of this polynomial, and we call that cubic. Anything cubed has a 3 exponent, so you can think of it like that. And then quartic is the last one that we'll use as a name, and that has a degree of 4 as the highest exponent in the entire polynomial. And just so you know, usually the polynomials are written in descending order, but sometimes they're not, like this example. So technically this should be written -45x to the fourth plus 8x because it's a positive 8x, and then plus 2. Usually they're written in descending order. However, sometimes they're not, so you just have to be aware of that. Okay, a couple more things here. We're going to do some operations on polynomials, which is pretty basic. You do need to be aware of your distributing laws here, and you need to be mindful of combining like terms in the correct way. And then after I do this simplification, I'm going to name it using the number of terms and the degree. So first thing I'm going to do is distribute my 3 to this parentheses. That gives me 6x to the third and 15x squared. Keep the plus sign there, and then I'm just going to tack on the 5x squared and the 10 and the -6x. So from here, keep in mind that we can only combine like terms. So the only terms that we can combine here are the x squareds. So my 6x to the third stays. 15 and 5 makes 20x squared. I combined those. Plus 10 minus 6x. And technically this should be written in descending order, so I'm going to rearrange the numbers just a little bit. I'm going to put my -6x first, and I'm going to end with my 10. Oops, that should be a 3. Okay? So very first example, very basic, distributing and then just combining like terms. Let's try this second one. It's a little bit harder because I'm going to distribute my 3 here, and I'll do that first. It makes 21x minus 6x squared. What you have to be really careful about here is you're distributing this -4, and that's something that always gets people, is you're distributing the minus sign, which changes the sign of everything in that second set of parentheses. -4 times 20 is -80. -4 times 3x is -12x. -4 times -6x squared changes to a positive 24x squared. And from here again, all we're doing is combining like terms. It looks like I can combine these x squared terms, and I can combine these x terms. And typically we write them in descending order. So negative 6 and 24 makes 18. And those are my x squared terms. 21 minus 12 gives me positive 9x. And then I just have that negative 80 all by itself. Okay? Careful distributing negative signs. We have two more examples. This is your classic foiling example, or the distributive law again. You're taking your 4x squared and you're going to distribute it to both terms of that second set of parentheses, or that binomial. I'll do that part first. 4 times 2 is 8. X squared times x makes x to the third. And then 4x squared times negative 1 is negative 4x squared. Now I'm going to take my 5x and distribute it also to everything in that second binomial. 5x times 2x is 10x squared. 5x times negative 1 is negative 5x. Again, we just combine these like terms here in the middle. Get 8x squared, or to the third, excuse me, 6x squared, and 5x. And there we go, just combining like terms, and finished. Last example, and then what we're going to do is go back and we're just going to name all 4 of these examples. So I'm going to take my 6x squared and distribute it to everything in that trinomial. The third or second set of parentheses has 3 terms in it, therefore it's called a trinomial. So I'm going to do 6x squared and negative 2x squared. That makes negative 12x to the fourth. And then minus 18x to the third plus 60x squared. Now what I'm going to do is take my negative 3. Be very careful with that negative sign. You're distributing the negative to all 3 of those terms. So it's going to be a positive 6x squared, positive 9x, negative 30. So be careful with the negative sign again. And now we just have to combine our like terms. Only things I can combine here are the x squareds. So I have negative 12x to the fourth minus 18x to the third, 66x squared, 9x, and negative 30. Okay, and then last thing I wanted to do is go back at just these 4 examples and talk about whether they were cubic, quartic, binomials, trinomials, whatever, just practicing that vocabulary that we learned just a little bit ago. So zoom in on this first example again. This has 4 terms. We don't have a vocabulary word for 4 terms, so I'm just going to leave it as 4 terms. And what is the degree? The degree is 3, which makes it cubic. And again, that was just from the words up here, the vocabulary in that chart that we just filled out. So we didn't have a vocab word for 4 terms, so there's 4 terms, and that is just because here's my first term, second term, third term, fourth term. That's where I got that. It is cubic because of the degree 3. So each polynomial, you choose 2 of those vocabulary words, 1 from each of those charts, okay? Let's talk about this second one. Okay, it has 3 terms, 1, 2, and 3. That makes it a trinomial. And then the degree, the highest degree in this polynomial is 2, which means it is quadratic. So you will have a few homework questions that ask you to kind of decipher the vocabulary words from here. Okay, again, we have 3 terms here, 1, 2, 3. So again, it's a trinomial. And then the degree on this one, the highest degree is 3, which means it's cubic. So each of these polynomials has 2 of those vocabulary words with it. And this one is not that fun because it has 5 terms and we don't have a word for that. 3, 4, 5. So it just has 5 terms. I'm going to leave it as that. And then the highest degree is 4, which means it is quartic. Okay. So that's some vocabulary practice. Hopefully you got all that down. Make sure you have your questions circled or highlighted so you can ask me tomorrow. Otherwise, have a good night, you guys.